Welcome to EMH Math Portal. This is Irvin M. Howard serving as your EMH online math tutor. Today we continue our series with the properties of exponents, and this time we're going to use the rule raising a quotient to a power. The last series we looked at raising a product to a power. This time we're going to raise a quotient to a power, and based upon the formula, this statement, if A and B are real numbers and M is an integer, then the quotient of A and B raised to power M, you kind of distribute the power or the exponent to the numerator and the denominator. And look here, and this is exactly what you're doing. As you raise a power of a quotient, you are distributing the exponent or the raised power to the numerator and the denominator. And it depends upon how many bases you have in your numerator and denominator. That's how many times, that's what you'll do. You'll distribute those exponents or raised power to each base in your product for your quotient. And we'll do some examples to show you what we mean if you have more than one base in the numerator and denominator. You'll raise each base with a distribution of the raised power according to this formula, just like what we did the last time with products, raising a power to a product. And the value of B equals to 0, meaning that 0 cannot exist in the denominator, and that's usually the rule of thumb. Okay, let's look at some examples. I'm going to write some examples. I'm going to write the quotient of 2x squared, all right, raised to the power of 3, okay? Now, in this problem, we're going to distribute or raise the power of each element in the numerator and the denominator. In this case, you have 2 and then you have x squared. This is 2 in the numerator and this is x squared in the denominator. So what you do, according to the formula, you raise the power, all right, raise the power of 2 to the third, and then you do this for x. Now x is already squared, so what we're going to do is, as we raise the power of 3 to x squared, this represents a type of x squared raised to the power of 3, okay? And again, this looks like this is part of the raised to the power, applying the power rule. As we apply the power rule, right now, this is the power rule, all right? So this is simulating A raised to the power M to the power of N, which is the product of both the exponents. And you remember from our last series, and this is what that is, all right? So this equals to, just remember to apply the different types of properties when you notice that there's more than one property being worked out or being used in each of these problems, okay? So this raised to the power of 3 to the raised to the power of 3 will equal to 8 over x to the what? 6, all right? So that gives you 8 over x to the 6, all right? Okay, let's do another problem. What we'll do one for a negative exponent, and I'm going to show you the first way to do it before we look at another type of quotient rule raised to a power using a negative exponent, and we're going to show you something different, but I want to show you this example first. Okay, we have 4x raised to the power of negative 2 over y to the third. I'll put it up here. Okay, and that's the quotient raised to the power of 2, all right? Now, this time we have 2 raised to the power. This is negative, okay? Like we done always, we're going to distribute the power of negative 2 to each component in numerator, and then also distribute the negative 2 to the denominator. By distributing, we're going to raise the power to each of the components in the that make up the product of the bases in the numerator and denominator. So let's do that first. So we're going to raise the power of 4 to the negative 2. All right, and then we're going to also separate your x with parentheses, little parentheses inside. All right, so we have x just to separate what we have. All right, because we have to identify x raised to the power of negative 2 is already there, and we're going to raise again as a negative 2. All right, over y to the third raised to a negative 2. And this is all within, all of that is the quotient, okay? All right, all of that is the quotient. So we work inside the parentheses, excuse me, and then we work our way out. And then what we're going to do later on, we'll introduce another technique that allows us to work within the parentheses and then work our way out by looking at the different operations when we're looking at exponential expressions. Okay, so we work inside. So we have 4 raised to the power of negative 2. So let's keep it right now, okay? Because in simpler terms, we'll say that for last. 4 to raise to the power of, negative 4 raised to the power of negative 2. And then when you multiply, take the products, again, this is using the power rule, all right? Because you have a raised power with another raised power. So you take the product between those two exponents, and that will give you a positive 4. Okay? And then when you raise this to a power of negative 2 to y to the third, you'll get y to the negative 6. All right? And then the simple thing, what we need to do, right now that we distribute, all of them are gone. Okay? Now, remember when we have negative exponents, okay? And I told you a trick that you write the problem based upon if you have negative exponent. The only way to make the negative exponent simplified as a value positive exponent, you use the negative exponent formula or the property. All right, and you remember that property. All right, which is a raised to the power m equals to 1 over a raised to the power m, and that makes it positive. Okay, that makes it positive. Now, to simplify exponents, you need to simplify, especially exponential expressions. You can't have negative exponents. In some cases, when you have simplifying exponential exponents, exponential expressions. All right, so what we're going to do, we're going to do the trick again that this right here is in the numerator. All right, so any raised power will make it reverse. It'll be the inverse of it. So this right here will be 1 over 4 raised to the power 2, but instead of writing it that, let's just write it and put it in the denominator because that's the same thing. That's what it is. All right, so we have x to the 4th, which is not negative, so it remains at the top. So you have 4 raised to the power 2 that comes to the bottom, all right, because it's in the denominator. It's the same thing as 1 over 4 raised to the power 2. And then in this one, since this is negative in the denominator, when we write it based upon this, all right, this is going to be 1 over y to the 6, which makes it positive. But instead of writing it that way, let's switch it because it's going to still be the same. So instead of switching, writing 1 over y to the positive 6, all right, when we write 1 over y to the positive 6, let's write it y to the 6 up here, all right? And I'll show you how we got that, all right? I'll show you how we got that. All right, so we have 4 raised to the power 2, and then if we simplify it, we have x to the 4th, y to the 6th, and if we simplify y to the 4th power 2, that gives us 16. All right, that gives us 16. So this is your answer, which is y to the 4th, y x to the 4th, y to the 6th over 16. Now let's come back and look at this one. All right, so if we come back here and work it out and use the formula, all right, so I'm going to show you this is for the shortcut. So if students recognize the positions of the exponents, all they have to do is just switch the positions in the numerator and denominator. So if you have a negative exponent with a base of a negative exponent, that means that if it's in the numerator, it goes to the denominator. And likewise, if you have a negative raised power exponent in the denominator, then it goes to the numerator. All right, let's show you that theory. So if we write it based upon the formula, you'll have 1 over 4 to the square of 4 to the power 2 times x over the 4, okay? And then you have 1 over y to the 6, all right? So this gives you a type of division between exponents, and usually if you do it that way, all what's happening is that you're going to have a division between them, and I'll write it like this, all right, so that you can see it. So what this means is that if you break it up into 2 parts, all right, you're going to have a reciprocal of this, all right. So when you write it like this, we can't leave it as a we can't leave it like this because we have a division between fractions. So what we do is we multiply, all right, we multiply by its reciprocal, all right, we multiply by its reciprocal. So this, what, you know, when we divide between 1 over y to the 6, that's what it really looks like, all right, that's what it really looks like. We multiply by its reciprocal, y over 6, all right, which is equals to y over 6 divided by 4 raised to the power of 2 is 16, and plus with this right here, we bring it back here, which is x to the 4, and that will still give you x to the 4 and y to the 6 over 16. All right, well, you can see my face right here. So to make things simpler, instead of doing all of this, why not recognize that when you have a negative exponent in the numerator, it, you know, just switch it to the denominator, and if you have a negative exponent in the denominator, just switch it up to the numerator. I hope that's helpful. This is Irvin M. Howard. I hope you understand and get a feel of using the properties. And hopefully I'll continue to show you more examples by demonstrating more exponential expressions using all of the properties that you've come to know right now. This is Irvin M. Howard. Thank you for viewing EMH Math Portal, and have a good day. And again, life is worth living.